This will be Module 2 of our basic DC system testing and maintenance course. Module 2 will cover environmental, health, and safety. Again, this training is comprised of 5 modules with exams on each module. Completion of the modules will provide the knowledge factors required for CEUs. Additionally, there are practical factors that must be completed in a lab simulation or on the job. Completion of these practical factors will provide a certification in basic DC systems. This certification means the trainee is capable of executing basic testing, maintenance on battery cells, cell lines, which are battery banks, and chargers. The trainee should follow along in the trainee guide. The exam links are in the electronic version provided. Let's look at the objectives for the entire course. Upon completion of this session, you'll be able to explain the basic terminology and theory associated with electrolytic cells. This was covered in Module 1. Explain DC system safety associated with electrolytic cells and cell lines, which is covered in this module, Module 2. Describe the acceptance testing procedures associated with electrolytic cells and cell lines. Describe the maintenance, inspection, and testing associated with electrolytic cells and cell lines. Explain the characteristics associated with lead acid and nickel cadmium batteries. Again, this module is devoted to battery safety. Due to the complexity of batteries and systems associated with batteries, there is no single source for hazard analysis and mitigation. This training will approach the safety aspect from 3 separate viewpoints integrated into a single safety concept. First is the foundation of the construction and installation in a general sense from OSHA 1926 Subpart K, Standard 1926.441, batteries and battery charging. Secondly, we will look at the battery hazards through the SDS or safety data sheets. The 2 that we will use are attached to this lesson, one associated with lead acid and the other nickel cadmium. Finally, we will look at the electrical hazards from the standpoint of both the manufacturers and NFPA 70E. There are 2 issues with the installation of batteries and battery chargers that we must take into consideration as a testing and commissioning group. We must inspect the installation for safety compliance along with functionality, and we must maintain safety during the installation and especially the commissioning phase. We must therefore be familiar with the OSHA construction regulations and manufacturer's instructions as it pertains to installation and commissioning. First, we'll look at the OSHA standard. OSHA 1926 Subpart K Standard 1926.441. Batteries of the unsealed type shall be enclosures with outside vents or in well-ventilated rooms and shall be arranged to prevent the escape of fumes, gases, or electrolyte spray into other areas. Ventilation shall be provided to ensure diffusion of the gases from the battery and to prevent the accumulation of an explosive mixture. Racks and trays shall be substantial and shall be treated to make them resistant to electrolyte. Floors shall be of acid-resistant construction unless protected from acid accumulations. As for PPE, face shields, aprons, and rubber gloves shall be provided for workers handling acids or batteries. Facilities for quick drenching of the eyes and body shall be provided within 25 feet or 7.62 meters of battery handling areas. Facilities shall provide for flushing and neutralizing spilled electrolyte and fire protection. Battery charging installations shall be in areas designed for that purpose, and the charging apparatus shall be protected from damage. When batteries are being charged, the vent caps shall be kept in place to avoid electrolyte spray. Vent caps shall be maintained in functioning condition. Let me help with why this is important for you to know and understand this. If you are doing acceptance testing and commissioning, you must ensure that all of these conditions are met And if not, you need to annotate this and note it so that the owner or the construction company can deal with the issue. Now we'll look at some of the requirements of the manufacturer's installation instructions. All personnel working with DC systems must be properly trained. All personnel working with DC systems must have knowledge of and understand the manufacturer's installation instructions. The battery contains acid or caustic, and the technician must avoid contact with skin, eyes, or clothing. You must have reviewed your SDS or safety data sheet. Wear a rubber apron, gloves, boots, and goggles or face shield when handling, checking, filling, or charging batteries. Keep water readily available for flushing spilled electrolyte from eyes or skin. Obtain medical attention immediately. Batteries produce hydrogen. Keep open flames away. Do not check the electrolyte level with a cigarette lighter or a match. Use a flashlight or permanent lights only. Do not smoke or create sparks when working on batteries. Never lay metal tools such as wrenches or other material on top of the batteries. Insulate tool handles or preferably use insulated tools to protect against shorting. Make sure that all battery connections are properly prepared and tightened to prevent possible injury to personnel or failure of the system. If the fluids is spilled on the floor, apply a strong neutralizer, like baking soda for acid and boric acid for NiCad caustic electrolyte. Check local regulations regarding the disposal of neutralized waste. Examine cells for container damage, misaligned elements, broken plates, or any other visible damage. Most of the safety measures we will cover can be found in Article 310 of NFPA 70E and Article 668 of the National Electrical Code, NFPA 70. To help understand some of the trade terms in Section 1.0.0 in Module 1 and our discussion here, we need to have a good understanding of the term cell line, and more specifically, the cell line working zone. A cell line working zone is the space envelope wherein operation or maintenance is normally performed on or in the vicinity of exposed energized surfaces of electrolytic cell lines or their attachments. In the next slide, you will see a figure that gives us a relative sense of the size of the zone. As you will be able to see, if the battery banks in the same room as the switchgear, you can easily find yourself in the cell line working zone. The space envelope of the cell line working zone, as shown in this picture, includes any space 96 inches above energized surfaces of electrolytic cell lines or their energized attachments, 96 inches below energized surfaces of electrolytic cell lines or their energized attachments, 42 inches horizontally from energized surfaces or their energized attachments for electrolytic cell lines operating at 1000 volts or less, and finally, 60 inches horizontally from energized surfaces or their energized attachments for electrolytic cell lines operating above 1000 volts. The cell line working zone shall not be required to extend through or beyond walls, floors, roofs, ceilings, partitions, barriers, or the like. If you'll look with me at section 3.2.1, we're now going to look at safety-related work practices. Safeguards for personnel include the consistent administrative enforcement of safe work practices. Safeguards include training in safe work practices, cell line design, safety equipment, PPE, operating procedures, and work checklist. Article 310 and 320 of NFPA 70E alone are inadequate to protect personnel working on cell lines properly. This training is based on National Field Services cell line practices and in some areas will be more prohibitive than these articles. Qualified persons shall be trained and knowledgeable in the operation of cell line working zone equipment and specific work methods and shall be trained to avoid the electrical hazards that are present. Such persons shall be familiar with the proper use of precautionary techniques and PPE. Training for a qualified person shall include the following: skills and techniques to avoid a shock hazard. Between exposed energized surfaces, which might include temporary insulating or guarding parts to permit the employee to work on exposed energized parts. Between exposed energized surfaces and grounded equipment, other grounded objects, or the earth itself, that might include temporarily insulating or guarding parts to permit the employee to work on exposed energized parts. And finally, methods of determining the cell line working zone, areas, and boundaries. Qualified persons shall be permitted to work within the cell line working zone. When there is a need for an unqualified person to enter the cell line working zone to perform a specific task, that person shall be advised of the electrical hazards by the designated qualified person in charge to ensure that the unqualified person is safeguarded. Section 310.5 of NFPA 70E-2018 states as follows: operation and maintenance of electrolytic cell lines might require contact by employees with exposed energized surfaces, such as buses, electrolytic cells, and their attachments. The approach distances such as the limited approach and the restricted approach boundaries referred to in tables 130.4DA and 130.4DB shall not apply to work performed by qualified persons in the cell line working zone. These are the limited approach and restricted approach boundaries. Our policy is that any work conducted in the cell line working zone is considered to be permit required energized work within the restricted approach boundary. The only exception is if the battery effect voltage of the battery bank is dissipated below 50 volts DC to consider the cell line de-energized and all energy isolation from the charging sources is rendered electrically safe through lockout tagout. What this basically says is that most of the time we will have to have an energized electrical work permit to work on a battery system or a cell line up within the cell line working zone. An exception to these previous requirements is when the battery bank is located in the vicinity of controlled AC equipment and switchgear without segregation or movement through the cell line working zone is not associated with work in the cell line, then no energized electrical work permit is required, as long as the restricted approach boundary based on cell line voltage and table 130.4DB is not crossed. Now remember, folks, when we are using the term battery bank or cell line, they are both talking about the same thing. Arc flash assessments. Arc flash risk assessments shall be done for all routine tasks performed in the cell line working zone. The results of the arc flash risk assessment shall be used in training employees in job procedures that minimize the possibility of arc flash hazards. Before non-routine tasks are performed in the cell line working zone, an arc flash risk assessment shall be done. If an arc flash hazard is a possibility during non-routine work, appropriate instructions shall be given to employees involved in how to minimize the risk associated with arc flash. If the likelihood of occurrence of an arc flash hazard exists for either routine or non-routine tasks, employees shall use appropriate safeguards that shall include one or a combination of the following means. Insulation shall be suitable for the specific conditions, and its components shall be permitted to include glass, porcelain, epoxy coating, rubber, fiberglass, and plastic. When dry, such materials as concrete, tile, brick, wood. Insulation shall be permitted to be applied to energized or grounded surfaces. PPE shall provide protection from electrical hazards. PPE shall include one or more of the following, as determined by project management: footwear, gloves, sleeves for wet service, footwear, gloves, or sleeves for dry service, electrically insulated head protection, protective clothing, eye protection with non-conductive frames, face shields such as polycarbonate or similar non-melting type, preferably Arc Rated. The following protective equipment shall be available to employees performing any type of service on a battery with liquid electrolyte. Goggles and face shield appropriate for the electrical hazard and the chemical hazard. Gloves and aprons appropriate for chemical hazards. Portable or stationary eye wash facilities and equipment within the work area that are capable of drenching or flushing of the eyes and body for the duration necessary to mitigate injury from the electrolyte hazard. Battery safety involves a wide variety of hazards, mitigation, and PPE. Fortunately, our technology is keeping up. The jacket and coveralls shown are a multi-hazard material solution that provides protection from acid, alkali, and arcing up to 14 calories per centimeter squared. This PPE is ideal for work with battery cells and DC systems. In conclusion, this training covers the essentials, but to thoroughly understand the hazards, you need to review the SDS or safety data sheets for the electrolyte additionally. The technician must understand they are dealing with shock, arc flash, and chemical hazards that, in combination, if not properly mitigated, can result in battery explosions and fires. The key is to eliminate the ignition source, which by the way also eliminates the arc flash. The battery chemistry will produce fuel and oxygen, two sides of our fire triangle, just simply waiting on heat or a spark. This concludes this module. Let's review the course objective for this module. Upon completion of this session and the review of your trainee guide's SDS sheets, you will be able to explain DC system safety associated with electrolytic cells and cell lines. This concludes Module 2 of the Basic DC Systems Testing and Maintenance course. Make sure to become familiar with the 2 SDS sheets included in your trainee guide before taking the exam. If you have any questions or need clarification on the information in this module before you take the exam, contact the instructor at 972-589-7448. You should now refer to your trainee guide and take the exam. If you fail, the instructor will receive an email and contact you for course remediation and retake.